2. So the purpose of this lab is to examine the charges and their interactions in everyday objects, just as it was in the first lab. But for this lab, we'll estimate the amount of charge on tape necessary to float one above the other by modeling line charges rather than point charges, which will be a more accurate measurement than the previous experiment. The fundamental principles we'll be using is Coulomb's law again, Newton's second and third law, which the second law is basically force equals mass times acceleration, and the third law, which states for every action there's an equal and opposite reaction, which we'll see later on in the code. And then the superposition principle, which basically states that once you find the electric field on individual points, you can sum them together to find the total electric force, and that the electric force equals the electric field times charge Q. So for the method, you're just repeating experiment 1, where you charge 2 different U-tapes and you float the U-tapes above each other and measure the distance. And using that, we'll find the force used to actually float the U-tapes against each other. But for this time, we'll just be using line charges rather than point charges. So it's just a different method of measuring the charges. So my data from the experiment, my tape mass was 2.03 times 10 to the negative 4 kilograms. My tape length was 0.203 meters, and the distance between the U-tape was 0.0306 meters. My original magnitude of gravitational force was 1.99143 times 10 to the negative 3 newtons, and the charge was 1.69342 times 10 to the negative 8 coulombs. So the assumptions for this lab is that you ignore air resistance on the moving object and assume that each U-tape you made had about the same amount of charge evenly distributed along the length of the tape. So here's my coding. I have my data from the lab with the scale factor and the acceleration of gravity, and then my mass, and this is my original estimated Q from lab 1. So then creating a function for the electric field, which I used an equation for lab 0 that just returns the electric field, which you'll see later on in the code. And then so I created a for loop that iterates through each piece of charge in the tape. So what it's basically doing is it's calculating the charge for the number n that I created. For this n, it was given that n equals 5, so it's going to do 5 iterations, but I changed it to do n equals 20, so instead I'll be doing 20 iterations. So for each for loop, it calculates the E field due to the E field at the top tape due to the bottom tape, and then the electric force, and then you just create the arrows and using the scale I created earlier. So this also creates the arrows that will have the electric force at the top due to the bottom U-tape, and then the gravitational force due to gravity, and then it just calculates the magnitude of electric force and the magnitude of the gravitational force, which should be equal, because if you're using Newton's third law, for every action there's an equal and opposite reaction. But instead, when I used the charge I got from lab 1, my electric forces and gravitational forces was not equal, and the electric force was much smaller than the gravitational force. So to alter this, I played around with the different Q's until I got about as close as I could get to get equal and opposite reaction for the magnitude of the electric force and the gravitational force. And these are my results. So what if I had modeled each of my tapes using a single point charge in the previous lab? So using point charge modeling, the magnitude of the electric force would have been much smaller than the gravitational force, as you saw with the first results I got from my computational models. And the estimates differ because they use a different they use a different process of calculating the charges. So the line charge model is more distributive charge throughout the tape, which would be more accurate because it is basically using the law of superposition, the superposition principle, to calculate the charges. So it just takes the point charge from each of the points that it iterates, and then it sums it all together, which would just be more distributive and more accurate than the single point charge method. So in my conclusions, the results showed that the charged piece of tape was 2.88611 times 10 to the negative 8 coulombs, and the magnitude of the electric force was approximately 1.99142 times 10 to the negative 3 newtons, as determined by the computational model. This was found using Coulomb's law and the superposition principle. Thank you for watching.